Hello everyone, and welcome back to the Fluctus Channel. Europe's Airbus A400M Atlas was created to solve a problem military planners had faced for decades. Nations needed an aircraft that could carry heavier equipment farther than traditional tactical transports, yet still use short, rough airfields closer to frontline operations. The program was developed for European air forces seeking replacements for aging C-130 Hercules and C-160 Transall fleets, combining strategic range with tactical flexibility. The first A400M flew in December 2009, beginning the long transition from ambitious multinational project to operational heavy airlifter. The aircraft is built around 4 enormous Europrop TP400 turboprop engines driving 8-bladed propellers. Together, they give the Atlas enough power to move troops, vehicles, helicopters, pallets, and humanitarian cargo, while retaining the ability to operate from relatively austere strips. Its cargo hold offers roughly 340 cubic meters of usable volume, while the certified maximum payload reaches 37 metric tons, or about 81,600 pounds. That puts the A400M between smaller tactical transports and much larger strategic airlifters. Before any mission, however, that capability starts on the ground. Royal Air Force crews walk around the aircraft checking tires, landing gear, propellers, control surfaces, access panels, and the cavernous rear cargo compartment. Inside the cockpit, pilots power the electrical systems, load navigation data, review fuel quantities, test communications, and verify engine and flight control indications. Loadmasters, meanwhile, inspect tie-down points and ensure every pallet or vehicle is secured against the forces expected during takeoff, maneuvering, and landing. When clearance arrives, the 4 turboprops spool up in sequence. Ground personnel remove equipment and signal that the aircraft is clear. The Atlas taxis toward the runway, its high wing and tall landing gear keeping the engines and propellers well above debris. At the threshold, power rises sharply. The 8-bladed propellers bite into the air, the heavy transport accelerates, and the nose lifts as the aircraft leaves the ground. The A400M can also demonstrate surprisingly aggressive performance for an aircraft of its size. During steep departures, the crew converts engine power into altitude quickly, raising the nose after liftoff and climbing away from the runway at an angle that looks unusual for a transport. That capability matters when terrain, obstacles, or tactical conditions demand rapid separation from the ground. Once airborne, the aircraft can descend into an entirely different environment. During Red Flag Alaska 26-2 in June 2026, and Royal Air Force A400M from No. 70 Squadron conducted low-level operations through the Joint Pacific-Alaska Range Complex, an exercise area covering about 120,000 square miles. Flying low allows crews to use terrain for masking while practicing the timing, navigation, and workload required for contested airlift missions. The Atlas can then deliver its payload without needing to land. During Swift Response 2024 in Romania, German A400Ms joined C-70s, C-130s, and Romanian transports in what NATO described as the largest Allied airborne operations since the Second World War. Between 1,200 and 1,500 troops from several nations participated, carried by 14 transport aircraft before paratroopers streamed from the doors over the drop zone. For heavier missions, the rear ramp becomes a road into the aircraft. Vehicles such as the American Joint Light Tactical Vehicle can be aligned behind the cargo bay, guided slowly up the ramp, positioned according to the aircraft's center of gravity plan, and chained to floor fittings. Loadmasters measure clearances and tension restraints before the ramp closes. That versatility begins much earlier on the production line. Major fuselage, wing, tail, cockpit, landing gear, electrical, and propulsion sections arrive from across Europe for final assembly in Seville, Spain. Technicians join the airframe, install engines and systems, test wiring and hydraulics, then move the completed aircraft through ground checks, engine runs, and flight testing. Before delivery, crews inspect the finished airframe from nose to tail, verify software and flight controls, and run the engines under power. Test pilots then take the aircraft airborne so technicians can confirm handling, navigation, propulsion, pressurization, and other systems before official customer acceptance. The result is a transport designed not simply to carry weight, but to move that weight quickly from distant bases to difficult operating areas. And another branch of the Hercules family approaches the same challenge from a very different direction. The LM-100J takes the proven Hercules idea into civilian cargo operations. Developed by Lockheed Martin as the commercial derivative of the C-130J Super Hercules, it follows the earlier L-100, which was produced from 1964 to 1992. The first LM-100J was rolled out at Marietta, Georgia, in February 2017 and completed its first flight 3 months later. Unlike military C-130Js, the LM-100J is designed for commercial operators that need a rugged freighter capable of moving outsized cargo into locations where ordinary jet transports may be impractical. Its high wing keeps engines and propellers farther from rough surfaces, while the rear loading ramp lets crews roll vehicles, machinery, pallets, and unusual loads directly into the cargo compartment. Production begins with major structural sections coming together in Lockheed Martin's Marietta facility. Workers join fuselage sections, install the wing and tail, route electrical wiring and hydraulic lines, and fit the 4 Rolls-Royce AE20-100 D3 turboprop engines. Each engine drives a 6-bladed Dowty propeller. Technicians then install avionics, cargo systems, landing gear, flight controls, and the equipment needed to turn the empty structure into a functioning aircraft. As assembly advances, the airframe is surrounded by work platforms. Teams inspect fasteners, seal joints, connect cables, and test individual systems before panels close around them. The landing gear is lowered, control surfaces are exercised, and technicians verify that cockpit commands produce the correct movement at the wings and tail. Once the aircraft is structurally complete, it moves toward painting, engine runs, taxi checks, and flight testing. The LM-100J therefore carries commercial freight, but its family history is unmistakably military. Few aircraft designs demonstrate that better than the specialized LC-130 Hercules used in polar regions. Operated by the New York Air National Guard's 109th Airlift Wing, the LC-130 is equipped with retractable skis that allow it to land on snow and ice while retaining conventional wheels for normal runways. The unit operates the world's only ski-equipped LC-130 fleet, giving it access to remote polar locations where prepared airfields do not exist. For Arctic missions, crews must think about surfaces that behave nothing like concrete. Snow depth, temperature, visibility, wind, and the strength of the ice or compacted snow all affect the landing. On approach, pilots lower the skis and carefully control descent toward a white surface where visual references can be difficult to judge. After touchdown, the broad skis distribute the aircraft's weight instead of allowing the wheels to sink deeply into soft snow. During Arctic Eagle 2020, the 109th Airlift Wing trained for operations supporting forces in extreme northern conditions. Its broader polar mission also includes transporting scientists, equipment, and supplies in support of research in Antarctica and Greenland. The LM-100J and LC-130 demonstrate how far the basic Hercules formula can be adapted. One turns military airlift engineering into a civilian freighter. The other uses skis to carry that same rugged philosophy onto frozen terrain. But another Hercules derivative was transformed for an entirely different reason. Instead of delivering cargo, it was designed to deliver sustained firepower. The AC-130 represents the most heavily armed branch of the Hercules family. Instead of using its cargo bay primarily for freight, the gunship carries weapons, sensors, communications equipment, and crews trained to orbit a target area and deliver precise fire from the side of the aircraft. Modern AC-130J Ghost Riders carry trainable 30mm and 105mm guns, while earlier AC-130U gunships combined 25mm, 40mm, and 105mm weapons. Before takeoff, that firepower has to be prepared one round at a time. Ammunition crews move shells and linked ammunition toward the aircraft, inspect them, and load them into the gun systems. Inside, specialists arrange ammunition so it can feed reliably during flight. Every weapon is checked for security, movement, and safe condition before the aircraft leaves the ramp. Maintenance teams work through their own checklist at the same time. On AC-130 gunships at Hurlburt Field, air commandos inspect engines, propellers, landing gear, panels, sensors, and mission equipment. The flight crew then enters the cockpit and begins system start. Electrical power comes online, displays illuminate, communications are checked, navigation equipment is aligned, and the 4 turboprop engines are started. The gunship is effectively becoming 2 aircraft at once, a transport, derived flying machine in front, and a coordinated weapons platform behind. Once cleared, the AC-130 taxis to the runway and accelerates under the power of 4 Rolls-Royce turboprops. The aircraft climbs toward the training or operational area, where the crew begins coordinating navigation, sensors, and weapons. Unlike a fighter that points its nose directly toward a target, the AC-130 normally attacks while banking into an orbit. Sensors track the target from the side as the aircraft circles. Fire control computers combine aircraft position, altitude, speed, sensor information, and weapon geometry to calculate where the guns must aim. Crew members communicate constantly so the pilot can maintain the correct orbit, while sensor operators identify the target and gunners prepare the selected weapon. Then comes the moment the entire preparation sequence was built around. On the range, the command to fire sends rounds out from the side of the aircraft. Smaller caliber weapons can deliver rapid bursts, while the 105mm gun provides a much heavier strike. Electronic warfare equipment adds another layer by helping the crew detect and respond to threats around the aircraft. Navigation systems keep the gunship precisely positioned, while infrared and other sensors allow crews to work at night and in difficult conditions. From the A400M hauling troops and vehicles, to Hercules variants carrying commercial cargo or landing on polar ice, these aircraft demonstrate different solutions to extreme mobility. The AC-130 takes that same airframe philosophy and turns it into persistent fire support, proving how radically a transport design can be adapted. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.